Hello everyone again, and as normal, I'll just ask you to go to makecode.microbit.org, which is at the top here, and I'm just going to wait maybe 10-20 seconds for everybody to join and for your page to load. So go to makecode.microbit.org, and you might as well just open a new project in readiness for today. Okay, so like I said, you'll find in the description, or you can type it in directly, makecode.microbit.org, which takes you to the free emulator for those of us joining for the first time. And when you click New Project, you will be brought up with the normal screen that we've seen for the last few days now. And today I want to talk about the physical world. The microbit we've seen can do some things on its own here, but I want to start attaching virtually in these experiments here, virtually to devices that you could purchase later on. Now the first thing we're going to look at is the actual pins themselves. There's actually quite a few pins. The main ones are 0, 1, 2, and we've got the 3-volt and the ground, which is important. That's like the negative, and we've got the positive values here. But we do actually have extra pins that you can buy other devices for to activate those pins. So there's actually a lot more than what's immediately obvious. And what we're going to do is show you what that might look like. So on the microbit, what you could do is attach devices using crocodile clips or just your own fingers even to make connections. So if you were to hold the ground pin there and with one thumb potentially on your right hand and then the other to grip it with the 0 pin there, you would actually make a connection because your body will conduct enough of the electricity to make the connection. You can actually use fruit as well to make that connection because of the water content within the fruit, as well as this, which looks like a very basic switch, which means that when this closes over, it makes this foil touches or makes a connection between these two bits, activating an alarm on your microbit. So there are lots of things that we can do with that microbit. So what that would look like is we would go to input and we would say on pin 0 press, and there we go, and you would simply make an alert. So we can do that using basic, and we can go to show icon, and that's it. On pin 0 pressed, show this icon, and when the emulator loads up, what you can do is you'll see now there's a 0 next to the 0 pin, which indicates that this pin is off. 0 meaning off, and when I click it, it goes to the full value here. You can actually go up and down depending on what you do, where you click it. You can actually give it a value because it's an analog, meaning there are different levels that you can use here, and I'll talk about that later with 1023 being the highest value. But when you tap that, if you had your thumb on the ground and the 0, that would come up and you could hold it. Now that's not the most exciting thing in the world to make a connection, but it can be very useful when you're making things like these switches. Now again, you could make yourself a very small and very limited keyboard with this, because what you could do is take out the show icon into the trash area. You could go to music and you could say play tone middle C for 1 beat. And if I move the headpiece over to the microphone, you should hear that, and when we press it, makes a sound there. And you could duplicate this and say actually pin, remember it's hashed because it's confused at the moment because I've got the same pin 0 here and pin 0 here. So I change that to 1, and instead of middle C, it brings up a keyboard, which is quite interesting, and you can click a different value there, middle G, and duplicate again for pin 2, and maybe make another one. There we go. So now I have a whole 3 notes to play with, and I can go. So, not the most exciting thing in the world, but you get the idea of what's possible there, and you can actually, using different things that you can buy, activate all these other keys or pins to get you much more of a range here across your keyboard. So, it's very simple, but it does work. Now, let's talk about stuff that's more interesting than that. Just pressing these buttons has its usages, but I'm just going to trash all these now. And now we're going to do something that we've not seen. We're going to go to the Advanced tab now. And I just did that by going down here and clicking on that little kind of black arrow there. And we've got extra things to play around with here. We will get to the game one at some point, but it's not as easy as all that straight away. What I'm going to go to, which is more interesting, is you might have to scroll down using either two fingers to scroll down or move your mouse here and drag it. You might not see the extensions at the bottom there. As you can see with mine, it was just nearly slightly off. You sometimes might miss it. You can press a command or control depending on a Mac or other computer, and you can actually zoom in and zoom out on your area if you didn't know that. It's very useful to know that shortcut, because if your program starts to get very big, you will be able to see more if you zoom in or zoom out to see what's going on. So don't forget that. So command and minus and plus on a Mac, or control on a Windows or Chromebook. So I'm going to click extensions here, and it should come up with very similar ones for you, but just in case it doesn't, we can manually search into here, and I'm after this servo one, so if you can see it, just click it straight away, or you can type in servo and press enter if it doesn't come up. And there are actually different things, so the screen you saw was not necessarily all the extensions. There's actually some quite interesting robotic stuff that we'll get to, but I'm after this one with the green background, which was on the first page when I pressed extension anyway. So either type in servo or just click straight away on that one, and give it a couple of seconds depending on your internet speed, because what it will do is it reloads the entire page, but it's dropped in a new area. Here it is, servos. That wasn't there before. So your extensions will enable extra features that aren't there with the basic setup on the microbit. So if I click on servo, a servo, by the way, is something that will move another object. So here's a picture that I had ready. These are all different types of servos. They come in a range of prices. If you're buying them off eBay, you can buy this normal which one is it? Yeah, the SG90, that's the one that's most common, and it's 180 degree servo, meaning the arm here, or the arms there, will move through 180 degrees only. The continuous servos that can go round and round and round, which are good for robotics, for wheels and things, they cost a little more, but are very useful. And when I say cost a little more, you can pick up these small SG90 servos for around about less than £1, I'd say, and the continuous ones maybe £2-3 for those. So not huge big bucks, but I usually buy them in tens because I like to do lots of different things with my servos, and the more you buy, the cheaper they come down in price. So on the servo, and we will see a picture of it come up here in a moment, we can set the servo to 90 degrees. Now let's do some button work for this. So input on button A, and here I'm just going to drag that in, and it says set servo, so your servo is going to be connected to the 0, and I'll explain that in a moment, set to 90. And what I'm going to do is duplicate that, which is a 2-finger click for those of you that remember, on a trackpad, or if you're using a computer, just the right click, and duplicate to this section here to number B, remember, because it's hashed because it's confused again. So I've got button A, button B, and I'm going to send that back to 0, and you can use a sliding scale, or you can actually just type the number in. And it's the same servo because it's the servo on pin 0. So let's have a look what that will do. I can select A to move it to 90 degrees, and B to move it back again. There we go. So 0 and 90 degrees backwards and forwards. If I want to do the full 180 degrees, just change that, and then you've got the full 180 and the full way back again. Now, while that may not look the most exciting in the world, if you want to make objects move or make a robot arm, this is what's key. A servo is the most important thing you can have in robotics, apart from maybe the motor wheels, but you can use continuous servos as wheels. So if I had to have one object for my microbit to make it more interesting, it would be a continuous servo or 180 degree servo, because you can't really do much without something that moves. Motors are great, but servos are much easier. Now, while we're here, I'm going to just show you here what the object is. So there's always 3 wires on a servo. There's the main power, 3 volts, that goes in. Most objects need a positive and a negative, so there's my negative going in, so there's my positive, the electricity flowing in and out of the servo, and 0, this pin, tells me how much to move that. As you can see there, I can press 0 and I can move that backwards and forwards. Now, you can have more than one servo. So what I'm going to do here actually is I'm going to say button. I'll show you what I'll do in a second. I'm going to duplicate this now, and this time I'm going to say actually button B. So it's confused now, so I'm going to go back to this one and do AB for this, and I'll show you why I'm going to do that now. And I'm going to add a servo onto pin 1. And at the moment, there we go, I've got my 2 pins. Now, we're seeing something extra on here. We're seeing a breadboard. Now, I'm not going to talk about that too much today, but I definitely will next week when we talk a bit more about robotics. And the breadboard that we have here just enables you to connect more devices at the same time. We can see here when I move to this area here, all of these lines, all this line on dots highlight, because this negative is connected to this negative to take me to the ground, and then I've got the positive is all connected to the positive here. So I'm sharing the power for these servos, but I'm individually controlling them with those buttons. So here, if I just press A, I'm going to move A around, and B, I'm going to move B around, but when I press AB, only one moved back because I'd only told servo 0 to move back, pin 0. So I can duplicate that and actually say, do you know what, I want them both to move back at the same time, and then I can press A to move that one, B to move that one, and AB to move them both back. If I wanted to control these motors independently or separately, I've kind of run out of buttons, but I could use gestures. So instead of here with A, B and C, what I'm going to do actually is drag out these pins, and I'm going to use A and B to control a third servo. So I'm going to duplicate that or bring it out of the servo here, and I'm going to add that to pin 2, so I've run out of my major pins, and I'm also going to add that to 180, and now I can have various arms of a motor working. Now, how am I going to reset this? I'm going to reset this by using the onShake command, and I'm going to remember that I need to duplicate to reset pin 2. So I now have 3 servos, all can be independently activated, so A to bring that one in, B to bring that one in, and AB to bring that one, and when I shake, they all go back again. If I wanted to control them individually, I could use separate commands maybe. So maybe I've got, I'll leave that one on there, but maybe if I duplicate, and I don't actually need all 3, so I can just drag out those 2 there. onShake is being used, so I can't use that. Maybe I have a tilt left for bringing the 0 back. Maybe I have a tilt right for bringing the next one back. And if I duplicate the next one, let's have a look. What could I do? Logo up, shake. I'm kind of running out of things to do here. Screen down maybe. and then I've got pin 0, pin 1, pin 2. So I've individually controlled them as well as controlling them all together. I've got the ability here to do A, B and AB. I've got the tilt left. I don't think it's allowing me to do that very easily, so we're running out of commands. There you go, that's that one. And just trying to get it there. Not quite working. Maybe got to tilt it down, moving it around. It's not quite working for those on the emulator. It's quite difficult to do this in practice, but in the reality that's how I would control them all. But here we can reset them by pressing shake to bring them all back again. So the emulator has some restrictions sometimes, and it's trying to do its best. It seems to like the right one. Doesn't seem to like the tilt left. Oh, there you go, it just happened there. And facing it down, I don't think they've given me a little button for that. Oh, there you go, I just kind of wiggled it enough. So difficult to show on the emulator, but it would work in real life. And now you could really get some cardboard, some servos, some bits of string, and you could connect these servos to real life objects to move them around. So I think that's really important to do. And there we go. Now, one of the other really important items, so you can either keep this, in fact I'll just delete all of these rather than do it. I'm just going to trash them as I talk. Now, what I'm going to say now is robotics is really fun, and you can control your robots using another microbit as a remote control. But what's best to do is allow your robot to control itself. And to allow a robot to control itself, ultrasonic sensors are really good fun, because you can an ultrasonic sensor will gauge the distance. So if your robot is moving towards something, or somebody puts something down in front of it, the ultrasonic sensor here, which looks like a pair of eyes, will sense that. Now, how the ultrasonic sensor works is by sending a signal out of one of these eyes as such, and then the receiving, if it bounces off an object, it receives it with the other sensor. Very much like a bat and a bat sonar system. It pings out a call, and if it bounces off a surface and rebounds back, it will register that distance. So how would we use sonar? We would go to make code microbit. We would go back down, if you need to scroll down again, to extensions. And you can see here we've got sonar. Again, if you need to type sonar in, we'll see that there are actually lots of different objects that you can get that use sonar. Here's a great example of some robots that you can purchase relatively cheaply, and they rely on the sonar at the front of this to move around the room on their own. And it's one of the more exciting pieces of technology that you can use with the microbit. So if you click on sonar, which hopefully was on the extension screen when you first logged in here, then you've got the one extra, and remember it takes about 5 seconds, or depending on your internet connection, some time to refresh. You've got new sonar. Now, this is a boring looking one, but it is the most interesting to use practically. And we're going to drag this in. You don't need to understand much of this at the moment. Ping just means sending the signal out. Echo means returning the signal, and I'll talk about the units in a minute. And to do this, we would need to forever be sending out a signal and receiving a response, or waiting for one. So I'm going to need a logic here. Go to our good old tried and tested if statement there, drag it in, and with the if statements we quite always seems to go to logic and drag in this comparison part, and we drag it in. Now, it may not be obvious, but this size, or this shape, is very similar to this shape here, because it does fit in. If you drag it over and let go, it just makes the whole bit bigger. And this is where we just say, send out a signal using pin 0, receive a signal, because you can't use the same pin just using any of the other pins. It doesn't actually matter which one you connect it to, but the wires, as you can see from the ultrasonic sensor here, they've got different objects here. You've got one that pings out the signal, the other that receives the signal, and then you've got your positive and negative using your 3 volt and your ground connector. So we aren't going to show you that here today, but the units we're going to talk about here is milliseconds. Now, I'm not really going to get into the speed of sound calculations that you can do, but there is a piece here about how fast it sends out a sound, which is the speed of sound, and then when it bounces off an object and returns, it calculates that speed and that distance. Now, we could go into science mode on you now, but thankfully for you, when you press the drop-down box, they've done the hard work for you. So you can actually, instead of measuring milliseconds, which has some science to go with it and some maths to go with it, we could possibly come to another time down the road. We can just click centimeters. That's much easier. And you could say if all of that comes back and does all the mathematical calculations and is less than 10 centimeters, then you can show a warning and stop any motors running or anything like that, or turn, and you can maybe do an X to show that, and that would say, you know, if that happens, else continue doing whatever you're doing, and we could represent that okayness with a tick. So it's something I wanted to talk about. We're not going to spend a huge amount of time on this now because the emulator can't show me any tests for this like we've done before. So using a sonar is one way of controlling your robot, and is possibly the one that we use the most, but I can't show it here. What I can show you here now, if I get rid of all of that, is something we've not looked at yet on our inputs, and what we've not looked at is compass heading. Okay, so what I'm going to do is show you basic, show number, forever, and drag the compass heading into there. Okay, and what that will do is it will show you where the compass is heading. Now, the emulator will allow you now to look at this and change the values that you've got there. So I'm just going to drag that there, and there we go. So we can actually show you the different directions that it is going in to emulate a driving microbit. So if you lay the microbit flat, and as it moves, you can actually give it some directions. So show the number there. We don't have to show it now, but what I'm going to do is show you how you could use it as an actual compass. But the reason why I'm going to do that is because we're going to potentially use the microbit to control your robot using north, south, east and west. And slide a bit of maths in like I always try to do as an ex-maths teacher. You'll notice that as you're giving your bearings in here, it's not really a true bearing, I would say, because a bearing usually has 3 digits, which is 0, 6, 0, but I will let the microbit away with that. So what we're going to do is we're not going to show the number, but we are going to leave the compass heading in. We're going to set a variable. And the variable, the number that is going to change, is my heading. What direction am I facing? So I can do OK. And what we're going to do now is we've got this value, and we can now go in and use some logic, which is there. And we're going to use a few here. I'm actually going to go straight in for the first time. Well, no, why break the habit of a lifetime? I'm going to drag in my same old and just press the plus a few times. And I'm going to do this 5 times. So I've got 1, 2, 3, 4, 5 gaps in there. And what I'm going to do is use my same old comparison chart. I'm going to drag it in here, and then I'm going to use my compass heading. Now we're going to use, in fact, I'm going to just do something slightly different here, and I'm just going to drag that out for a moment. We're going to use a new bit of logic that we've not used before, and it's an AND logic. So we're going to go to logic, and you can see here we've got ands and ors and nots. These are very important logic arguments with coding, because now I want to say if the bearing is between 0 and 90 degrees, or between certain angles, I'm going to show a certain heading. So I'm going to keep this nice and basic, and I'm going to drag in my logic argument here. The first time I've done this, and I'm going to drag it into here. And now you can see we've got the same shape we had before with these ones here, and we can drag that in there. So we're going to start to look quite complicated, and this is possibly the most complicated thing we're going to have a look at for the foreseeable future. And then I'm going to duplicate or grab another one from my logic variable, and I'm going to drag it in. Now this starting to look quite big. Okay, and I'm going to grab my compass heading and I'm going to stick it in here. I'm going to drag this out. Now don't get too bogged down now with the maths I'm about to do, because I'm going to do it for you so you can copy me. And I'm going to duplicate my compass heading as well. In fact, what I'll probably end up doing for this is trashing that and just duplicating all of this. So I'm going to say if my compass heading is greater than, and I'm going to say 45 degrees, and I'll show you this in a minute. And I'm going to duplicate this whole block. There you go. And is less than, and I'm going to use, you can use this to see, and maybe you'll gauge why I'm going to do this in a minute, because what I'm doing is I'm saying about here 45 degrees, then I've got my 90, and then I've got another 45 degrees on here, so 135 degrees. So you can copy the numbers and it'll all become obvious in a moment. Now I'm going to be specific on this one. I'm going to say greater than 45, and this time I'm going to say less than or equal. So don't worry if this is getting a little bit difficult for you. You can just copy exactly what I have. And what that's saying is, if it's between that, then show me the text, or show me the letter that I'm going to draw for you, which says east. I'm just going to have a look what that does. Now, we all know never eat shredded wheat is how I remember it. It's showing east right now because anything between 45 and here is more east than anything else. If I drag it out here, it's not knowing what to do because there's no other choices at the moment, but I'm going to make that happen now. And now what I'm going to do is duplicate, and be very careful where you're clicking your mouse or your fingers here. Can you see when I'm moving here now, I'm going to highlight the whole block, and I'm going to duplicate it and drag it in to here. If you don't get it right, just press the undo button down here and try and get the whole block, not that one, but the whole block. And I'm going to duplicate that a couple of times. Oh, you can see there, did too much, so press the undo button. Be very careful because you want to get everything that's there, and it is a little bit fiddly, but you do get it. It's worth it rather than doing everything else that you had. And one last time. In fact, I think I clicked my else too many times. Oh, there we go, press undo. Really fiddly this bit, but worth getting right. There we go. I've got 4 options that I'm going to change. In fact, I'm going to minus 1 here because I didn't need all of those. Oh, yeah, I did, sorry. There we go. And then I'm going to drag in and duplicate my letters. And I'm going to make north, south, east, west. So it takes a little bit of time, this one. But I've just duplicated everything. And I'm going to spend a little bit of time. After east, I'm going to go round the clock here, so never eat shredded wheat. Here we go. And then W. You can click and just drag to undo them all. I'm going to go for this as a W. There we go. And last but not least, I'm going to go for my north. Some people may have said I should have started with, but anyway. And if I haven't got any of these correct, you're getting to hopefully used to my style of coding. Oh, not there. I'm going to show an X to say something's gone wrong. Okay, and then you can pause any of these and you can have a look as you're going. It was greater than or less than or equal to 135. So I'm going to start this at 135 because it doesn't include 135. That's the important changeover point. And after I've got 135 there, I'd be going to 180. Then I've got 35 more than that. So I've got my 180, so plus 45, which is 225. Again, don't get too bogged down with the numbers there. I'm doing all the maths work for you, but you can have a look back and change that. And then as I come back round again from 225 there, it will go to west, which is 270. Then another 45, which will give me the 315, which is 315. Bringing me all the way back to 45. So this will now bring me all the distances south, west. There we go. Now there's something happening here because, don't know if it's else if, there we go. So I've got my 4 decision making tools, 315 and less than 45. So this is why we have the X. Brilliant. So let's just take you through what does work. So I've got this, brilliant, all the way around, fantastic. Now the reason why we're struggling now here between 255, sorry, there we go. I didn't do 225, did I? So this is why we have the X. It's really good for spotting your problems. So east, south, west, brilliant, all the way up. Now I'm going to have a problem around about here for north. North is having a huge problem, and the problem is because here the computer doesn't understand that you've got 315 all the way to 45. It doesn't understand. It's not going back round the circle. It's trying to say, oh, 315 all the way up, 360. It doesn't understand that at 360 degrees it resets itself. So you actually do need another one just for north. And again, don't worry too much if this went slightly above your head. It was the trickiest thing we're going to do. We wanted to do 315 to 360, including it. And then we wanted to say from 0 to less than 45. We had to separate north into 2 chunks. The chunk up until we had the idea here. There we are, north, and then the other chunk here. We had to separate it into those 2 chunks. So it was important that we used that X. That X was really useful as I tested all of the parts all the way around. It showed me some X's when there was some issues. So that X was very important and helps you to spot errors. And as I'm going around now, I'm not seeing any X's. There we go. Looks like I've got that north, south, east. And then what you could have, if this is your direction for a robot that's moving around, is you can have go north for X amount of time till your motors go, then turn this direction, then turn that direction. You can have different ideas for that. So compass is important, but to be honest, that's why I wasn't getting too fussed about it. I wanted to show you that servo is what we really use. We usually just say go forward until you hit an object, and then we use these servos, so the ultrasonic sensors together, distance, and then these servos to make things move around. So if you're talking about some form of robot wars, if you've ever seen Robot Wars, some sort of robot that goes around destroying things. These are the Robot Wars of my youth that go around. You'll need the motors to move the things forward, and then the servos to make all of these things move down and crush and spin and do all those kind of things. So you've now explored virtually what those things are. Again, don't worry if that last 10 minutes or so is a bit tricky. We've gone into some quite complex logic there with the ands, and especially that north throwing up a little bit of a problem for me. But we will go back a step next week when we talk about this. Now tomorrow's session will be pre-recorded because I teach on a Friday and I've got a lesson on during that time. So I'll leave a pre-recorded thing, and tomorrow's lesson is going to be free play gaming on the micro bit. So I've got a couple of games like Flappy Bird that you can press on the micro bit, and a few other little games that we can have a little go with, and you can edit them yourself, because the games are quite hard, but I'm going to give you the code and show you how to hack into the code to make your games better or harder or easier depending on what you want to do. So tomorrow is going to be Free Play Gaming as a pre-recorded. It'll come live probably just before 1, but around about that time tomorrow, and then I'll see you back on Monday for another live one. But don't forget to have a look at tomorrow's pre-recorded gaming session. It should be a nice bit of fun to end a strange week. So there we go. Hope you've enjoyed it. There we go.